Hi all. Now it's the time to discuss volume integration. So again, we can have an example of volume integral. So calculate the volume integral of a scalar field phi equal to x y z square over the prism shown below. So here the prism is shown here, in which here the x varies from 0 to 1 and y 0 to 1 and z 0 to 3. But the thing is, if you look at the lower area, the variation of x is depending upon the value of y, or the limit of y will depending upon x, because the lower shape is not in the shape of rectangle or cubic, so therefore the limit is not independent. The limits are dependent to each other. Okay, so first we can write the volume integration. So volume integration in general, we write phi times d tau. And what is d tau? So d tau is a very small volume element. So if you consider an infinitesimal cube and its sides we can represent that as dx, dy and dz. So therefore its volume can be as dx, dy, dz. So there are three integrations. So hence we can put three symbol of this integration. So there's a triple integral phi dx, dy, dz. Okay. Now what is phi here? The phi is x, y, z square times dx, dy, dz. So first I will perform the x integration. Thereafter I will perform the y integration. Then finally the z integration. So that is our strategy. But now while we are integrating, we have to put the proper limit. So what is the limit of x? So the x varies from 0. And what about the upper limit of x? The upper limit of x depending upon y. So that is one dilemma here. So because the shape is not actually the rectangle or cubic, sorry, the square. So therefore, the limit of x depending upon the value of y. That is when y equal to 0, the x varies from 0 to 1. And when y equal to 1, there is no variation in x. So the limit in x, the upper limit in x depending upon the value of y. So in order to find that, what you can do is you can find the equation of this line. So the equation of this line is found to be y is equal to minus x plus 1. This is when x is equal to 1, y equal to 0. When x is equal to 0, y is equal to 1. So therefore the limit is y equal to minus x plus 1. So therefore the x limit, we can just replace it. So the x is equal to 1 minus y. So therefore the x variation is from 0 to 1 minus y. Okay. Now what about the limit in y? The limit in y, again the y starts from 0. Okay. And it can go up to 1. And finally, what about z? The z varies from 0 to 3. So whatever be the value of x and y, the z varies from 0 to 3. Okay, so for all values of x, z varies from 0 to 3. And for all values of y, the z varies from 0 to 3. Okay, so this is our integration. So I will write this once again. So this can be integral 0 to 3, integral 0 to 1, integral 0 to 1 minus y, x, y, z square times dx, then dy, then dz. So in the first integration, we have to take only about x. So y and z can be kept as constant. So this integral 0 to 3, integral 0 to 1. So if integrate x, so it will be x square by 2. What are the limit? Limit from 0 to 1 minus y. Then we have y and we have z square. dy dz, integral 0 to 3, integral 0 to 1. So put the limit b1 minus y, the whole square, times y times z square, dy dz, and 1 by 2 can be taken outside. Okay, so how to perform the y integration? So we can take that as constant for as far as y is concerned. So this would be 1 minus 2y plus y square times y will become y minus 2y square plus y cube. dy. Okay, so that is integration 0 to 1, and z square dz can be taken outside. So we have to perform this integration next. So is equal to 1 by 2. And this integration will be y square by 2 minus 2y cube by 3 plus y raised to 4 by 4, and the limit is 0 to 1, and we have z square dz. And next we can just put the limit 1 by 2 is y square by 2 is 1 by 2 minus 2 by 3 plus 1 by 4, and we have integration 0 to 3 z square dz equal to 1 by 2. So we have to take LCM. LCM can be taken as 12. So 6 minus 8 plus 3 z cube by 3. The limit is 0 to 3. So 1 by 2. 6 minus 8 would be minus 2. So it would be 1 by 12. Then z cube by 3 will be 3 cube by 3 with 3 square, that is equal to 9. So it would be 9 by 24. Okay, so this can be written as 3 by 8. So that's all about this volume integration. Okay, so the volume integration, this volume integration is slightly difficult because we have taken a prism shape, but if it is instead a cube, then the integration would be very easy. So if the same integration, if you perform over a cube with some side 2, then the integration would be very easy because it will be a triple integration x y z square dx dy dz, and all this x y and z varies from 0 to 2. So there is no need to uh, connect the limit with the other variables. Okay, so all the variables are independently varies from 0 to 2 in the case of cube, or even if you take a box also, that is the case. But for prism, that is not the case. Okay, so here the limit of x and y are interconnected. Okay, now if you take a sphere, then it will be slightly more complicated. That is, the limit of x, y, z would be interconnected. Okay, so obviously you can do such kind of problem. So here, recall, we have discussed the volume integration of a scalar field. So similarly, we can perform the volume integration of vector field. So if you have a vector field V, if you take the volume integration, so this volume integration can be split into 3 integration: Vx d tau I plus Vy d tau j plus Vz d tau k. Okay, So this is actually the volume integration of a scalar field. Is the volume integration of another scalar field, is the volume integration of third scalar field. Because Vx is just a scalar, Vy is a scalar, Vz is a scalar. Okay, so the volume integration of a vector field is basically the sum of three volume integration of scalar field. So the volume integration of a vector field is sum of three volume integration of scalar fields Vx, Vy, Vz. But respectively, there will be unit vectors here, so that we have to keep in our mind. Okay, so I'm not going to illustrate it. Okay, so this is very straightforward. So this you can do it yourself. Okay, so that's all about all the three types of integration. So we have discussed the line integral, surface integral, and volume integral in detail. Now the only thing remaining in this module is we have to discuss the different theorems in case of the integral calculus, particular namely that is called the fundamental theorem of the gradient, the fundamental theorem of divergence called Gauss's theorem. So those things are remaining, so that we will discuss in next class. So thanks for watching this video. See you in next class. Bye.